You want to make 750 milliliters of a 6 molar solution of sodium hydroxide. What mass of sodium hydroxide, NaOH, will you need to make this solution? So this is a molarity problem, and our formula for molarity is moles divided by volume. So in this problem, we are given the volume, which is 750 milliliters of solution. So we're given our volume, and we are also given our molarity, which is 6 molar solution. Our unknown is the mass of NaOH. So how many grams of NaOH? That is our unknown, the mass. And now let's think, what do we want? What is going to be required for this, for the solving of this problem? Well, we're given molarity, we're given volume, and we're going to need to find the moles of the solute, so moles of NaOH. And then once we have the moles of NaOH, we can go ahead and convert to grams of NaOH. And also, volume is in liters in the molarity equation, so we're given milliliters, so we're going to also need the volume in liters. So we're going to have to do a conversion there too. So here is our overall plan in order to solve this kind of problem. First, I'm going to go right ahead and get the moles of solute. But before that, let me just get liters first. So let's get my milliliters converted to liters, and then once I do that, I'm going to plug in my volume in liters and plug in my molarity. I can use that straight, and then once I do that and get the moles of solute, then I'm going to convert moles to grams. That's my plan for solving this problem. So first things first, let's just do this quick step and convert milliliters to liters, which is fairly simple. We should be aware that 1 liter equals 1,000 milliliters, and if we are given 750 milliliters, and we'll convert that to liters like so, set it up over 1, multiply it by its conversion fraction, add milliliters on top, so I better put milliliters on the bottom, 1,000 milliliters, and then on top is 1 liter. Milliliters cancels out, and I get 750 L over 1,000, which is equal to 0.75 L. So 0.75 liters, and now I'm going to go on to my next step, which is just basically plugging in all the information. So I'm going to do that second, plug in the given information into the equation. So just as a refresher, here is the equation, and here's what I'm going to plug in. My molarity, I already have it. It is given 6m, so that's going to be 6 equals moles of solute. I don't know, so I'm going to let that be on my variable. And my volume, I just found that in liters, 0.75 liters, and I need to isolate this moles of solute, so let's multiply both sides by 0.075. 0.075. There we go. It cancels out over here, and my moles of solute equals 0.75 times 6, which is 4.5 moles. And there we go. I found what was required up here, moles of NaOH, which is 4.5 moles. And now that I have the moles, I can move on to the last step in my plan. So my third step, step 3, convert moles to grams. That's step 3. So in order to convert moles to grams, what's required? The molar mass of NaOH. And so going to my periodic table, I'm going to find that the mass of sodium is 22.99, oxygen 16, hydrogen is 1. So Na is 22.99, oxygen 16, hydrogen is 1. I'm going to add them all up, and plus 16 plus 1 is 39.99 grams per mole. There's my molar mass. So now that I have the molar mass of NaOH, let me go ahead and convert moles to grams. So I'm given 4.5 moles NaOH. I'm going to set it up by putting it over 1 times, and now I have moles up top in the numerator. I really want it to cancel. I want it to cancel, so I'm going to put moles in the denominator, 1 mole NaOH, and that leaves me with 39.99 grams NaOH and up top. And then when these two fractions multiply together, the moles of NaOH cancel out. So now I just multiply across the top, 4.5 times 39.99, which is going to be 179.955 grams of NaOH, and 1 times 1 is 1. This divided by 1 is going to be itself, so this is actually going to be my answer. And now I've solved this problem. My final answer, which is what we were looking for, the unknown, which is grams of NaOH, 179.955. There we go.